Chapter 13.3 starts off with sequential searching, and we start with the search of an array. And the easiest way to do this is to loop over the elements of the array every single time and check to see if the target is in that array. It's a sequential search because it examines every element in the sequence. To write this, we are going to have a method, public static int, and we're going to call it index of. We're going to take in a parameter of int. We're going to take an array as a parameter. It's going to be of type int, and we're going to have it as list, and we're going to take in whatever number, whatever value we want to try to find, and we're just going to call that value. Inside of here we have a for loop, so we can go through every index in our array. We're going to have a temporary value, which is x, and set it equal to 0. Then we're going to have x is less than list.length, and then we're just going to increment x every single time. We're going to have an if statement in here. If list x is equal to value, we're just going to return x like this. And then if our value is not found, we can return -1. After we work in our method to test this, we can make a main method. We can make an array of type int and call it list in our main method. And then we can just sys out. And then we're going to have our method. And we're going to have list inside of it. We're going to pass list, but we also have to have the value that we want to find. So let's say we want to find the value 6, like this. And we're going to run it, and it's going to give us it at index 5. And if we were to run something like 9, which is not in our array, we're just going to return our -1. When our algorithm searches for an integer that is not in the array, it runs slower. That's because it can't exit the loop early by finding the target. If we ask for the value 1 here, the loop is just going to run once because it's going to find its target and then return 1. However, if we have thousands of numbers in here and we don't have a specific value, it's going to have to run through this entire loop and then return the -1. This scenario raises the question of whether we should judge the algorithm by its fastest or slowest runtime. Often what's most important is the expected behavior for a typical input, or the average of its runtime over all possible inputs. This is called an average case analysis. But under certain conditions, we also care about the fastest possible outcome, the best case analysis, and or the slowest possible outcome, the worst case analysis. In this algorithm, the average search looks at approximately half of the array, which is linear.